Let me get my screen share up and running and we'll get started. All right, cool. Actually, before I do that, let's talk about a couple things. So I want to make sure everybody knows where the course repository is. Let's see here. I see somebody maybe direct messaging me. If you can post in the thread, I will respond to that because I can't see it right now. So I want to make sure everybody knows where the course repository is. If you look in Learn, let me see if I can find this in Learn. It should be in the Welcome or Initialize section somewhere in Learn. You'll see links to this. And I'll just paste this in right here. This is the course repository, our GitHub repository. This is sort of where the syllabus lives, and each topic that we cover here. I'll go through this. I'll just screen share this. So each topic that we cover will be linked to in the entry for each day. So today is day 2, Wednesday, July 7th, 6 to 8 p.m. Pacific. And then you can see we have links to Introduction to Python and Python Basics. So if I come to these, I do hear somebody's microphone on. If you can please make sure you're muted. If you come in here and you go to the bottom of any of these, you will see links for all the homework. So if you you'll just come to the day that you want to find the information on, and you'll go to the topic and scroll to the bottom, and there'll be links to the homework. And I do expect everybody to have these pages up to kind of go through. That's essentially what I'm presenting out of in my text editor. It's the same repository. It's just I'm showing it through my text editor rather than my browser. And yeah. That way you can follow along and kind of go through what I'm going through at the same time. Cool. All right, let's get going. Okay, hold on. Okay. There's a cacophony of unmuted mics. I know it takes some getting used to, but cool. After I'm screen sharing, I won't be able to mute your mic, so. Here we go. Okay. There we go. All right. So let's pick up where we left off yesterday. We were talking about comments. And I was just going over some different reasons that you might want to use comments. So one of the most common things you would want to use a comment for is just for turning on and off a line of code. So if I have this code here, this is a print function, And basically all this does is it prints out whatever I put inside of these parentheses. And by print doesn't mean that it like activates my printer. It just prints it, makes it visible on the console here. So if I want to say, hey there, I'll run this code, and then you can see it says hey there in my console down here. So it's just a way of monitoring kind of what's going on in my code on a given line. So if I want to turn this line of code on and off, I can just comment it out like this. I can put a hash mark in front of it. I can also leave a comment at the end of the line by putting a hash at the end of the line and then saying, just leaving whatever comment that I want. So I could say prints or displays, hey there to the console, maybe on the console. Cool. So that's probably the most common use for a comment is just you write a little code. You don't necessarily want to delete it. You just want to like turn it off for a minute and do something else. We got, oh my gosh. Sorry, we got microphones on. I've got 3 people with mics unmuted. Okay, we'll get used to it. It's okay. Okay. So that'll do it. That'll do it for comments for now. I think everybody gets comments. So basic Python constructs. So we'll cover some data types and simple operations on those types and assignment and the assignment operator as well. So if you're not familiar with the concept of a data type, basically a data type is a way of treating information such that it's useful to us. Sorry. I hear somebody's mic. Okay, we've got 2 more unmuted. Okay. One of those days. Okay. So a data type is a way of storing information such that it can be dealt with under certain terms. It can be dealt with in a specific way, right? If I wanted to, let's say I wanted to store information that was textual in nature, right? So if I said my name is Clark, my favorite number is 7, right? So this would be what we call a string, and we can make a string. I can tell Python that I want this to be the string data type by putting quote marks around it. Now I can use single tick quotes like this, or I can use double tick quotes like this. So either way, doesn't matter. It's still a string. I was talking about PEP8 convention the other day, and single tick quotes are specified as the conventional standard way of making a string in Python. Let's see. So I actually prefer to use double tick quotes, and the reason is the apostrophe character is the same character as a single tick quote. If I wanted to say like theirs, if I wanted to use a word with a contraction in it, like, right, that this character is a single tick quote character. So if I try to put that in single tick quotes, it's going to conflict with that quotation mark. So there's a way around that, but the thing I do is I just put it in double tick quotes, and then that way it doesn't conflict. So there's no real difference between a string that's created with double tick quotes or single tick quotes. It's just, you know, it may interfere with a double tick quote character or a single tick quote character. And since I find myself using apostrophes more than quotation marks in strings, I prefer to use double tick quotes. That's my reasoning. You can make whichever decision. If you want to do the conventional way, you can use single tick quotes. If you want to do the weird way, you can do what I do. Okay. So if I look at this information, it's laid out as text, and it will be treated as textual information because I have it in those quote marks, and that tells Python that I want to treat this as a string. So if I notice, and I included a string that has a number character in it, I could have multiple numbers in here. I can just put whatever number characters I want. But it's important to not remember that this isn't actually a number. This is still a string. These are the characters 7 and 3. This is not the number 73. So that's an example of how you could look at a number, for example, as a set of characters or as a numeric value. So we're going to get back to strings more in the future. I don't want to go too in depth with these right now. We're going to dive deeper into them. They're slightly complicated, not terrible, but slightly complicated. But we are going to dive into number types. So if I actually want to represent numbers, the number 73, for example, I just type it like this. If I want to print this number, I can stick it in a print and it'll print it out. 73, so I can use basic mathematical operations. 73 plus 7 is going to be 80. We can do plus, minus, times, divide. There's another kind of division called floor division. There's another operator related to division, which is the remainder, but it's called the modulo operator for modulus division, which it's a fancy way of saying remainder operator. Oops, there we go. We'll get to that in a second. So we looked at addition, there's subtraction. Uncomment the rest of these. So 73 times 7 is 511. 73 over 7 is 10.42, etc. 73 floor divided by 7 is just 10. And then 73 modulo 7 is 3. So this is like saying if I divide 73 by 7, what's the remainder? And the remainder is 3. Cool. Okay. So these data types that I'm using inside this print right here. These are what we call integers. Integers can be any positive or negative whole number values. So they can't have a fractional number component, right? So notice that this number has a fractional component. this is actually not an integer. This is what we call a floating point number. You're probably used to calling a number like this a decimal. In computer science, we refer to this as a floating point number because we think about this point as being able to float. And that's more an artifact of the way we think about storing a number like this. If you think about like how you would allocate memory to a number that has a decimal in it, you have to allocate a value to the whole number portion and a value to a part of the number to the fractional component. And then you also have to allocate information, about where that dot goes, or where that point goes. So we call it a floating point number. We usually just call it a float for short. If all of that sounds like a lot, don't worry. You don't have to understand like how the information is stored and processed on the hardware level. We don't need to get into that at all. Just know that if a number has a decimal point in it, we call it a floating point number. If it does not have a decimal point in it, we call it an integer. And there are times when you have to use an integer, and there's times when you have to use a float. So mostly they're compatible, but there's some times where they're not compatible. So let's just mess around with floats a little bit. So if I make these, I'll just do 0.0. So I just make these numbers, one side of these expressions, if I make them floats, you can see the results are now all floats, right? And it doesn't matter. So this shows us a couple important pieces of information. One is that if I mix floats and ints in an operation, it always results in a float. So mixing floats and ints always results in a float. The other is that we can mix floats and ints. Floats, and ints in one operation. There we go. So we can mix number types together in a single operation. And the reason I mention this, I mean, this might seem intuitive or like, yeah, of course, like why wouldn't you be able to do that? Or it might seem really strange. The reason I mention it though is I'm not sure about everybody's background. There are some languages, every programming language that I've ever worked in has integers and floats, or at least numbers. And some languages won't let you mix operations between integers and floating point numbers. They'll only let you do a mathematical operation between two types that are exactly the same. But Python is rather forgiving in that regard. Cool. Excuse me. All right. And just for good measure, I'll just show this. It doesn't matter which side we do it on. Oops. There we go. We still get floating point numbers returned, right? So notice I haven't actually changed the values of the numbers when I've changed them from integers to floats in either case. I haven't changed their values because, the value 7 is equal to the value 7.0, for example. It's often really useful to be able to see if two things are equal. Obviously, right now we're dealing with just numbers, just literally typing in numbers into the console. So it's obvious if something's equal, more obvious, but oh no. Oh. Apologies, this Zoom meeting is going to end. Shoot, I forgot about that. Well, we'll have an early intermission and I'll figure out something to do over that break. Yeah. Okay. Sorry about that. So if I want to see if two things are equal, and this is worth remembering, I can use two equal signs right next to each other like this. This is called the equality operator, and it checks if two things are equal. So I can say 7 equal to 7.0, and you're going to see that this is going to give us true. This is going to say true back. If I say 7 equal to 7.1, that's going to say false. And that brings me to another important data type. So this data type is called a Boolean. So Booleans, it's a fancy name, but I promise it's a pretty simple concept. Booleans, shortened to bool, often we'll just call them a bool in Python. So a bool has two possible values, either true or false. And that's it. And it's important to know about Booleans because a lot of operations give you back a Boolean value, right? So this operation, for example, checking equality will give you back a Boolean value. And there are places in your code where that will be very useful. When we get into control flow, which is, I'm not sure if we'll get into that tomorrow or the next day, we'll be getting into it fairly soon within the week. When we get into control flow, Boolean values are going to let us check conditions. This is a condition. And if that condition is true, it'll allow us to run certain code, and if it's false, we'll run some other code, right? So Boolean values, it's a simple idea, but this is essentially what allows us to write code that's going to be dynamic. Cool. We've got a couple questions. I have a few people asking about the equality operator versus the assignment operator, which is single equals versus double equals, or rather the other way around, sorry. And we've got some other things in here as well. Oh, this is, okay. Somebody's asking about my environment. The environment we want you to start setting up is VS Code. It looks similar to this. I use this because this is the tool that I am familiar with, and I just use basic features in it. But VS Code is a much more capable tool ultimately. But this is just my kind of old school text editor that, yeah, anyways. So as for the single equals versus double equals, we'll get to that in a second, I assure you. So we're about to cover that in a few minutes. Cool. Let's see. Okay. I think I got everybody's questions in there. if you have something that's pressing, just feel free to @ me and I'll get back to you as soon as I can. Okay, so we looked at equality. We looked at basic mathematical operations for integers and floats. And we looked at the Boolean data type as well. If you ever want to get the type of something, there's a tool built in called type. It's a function. So I didn't really, I just mentioned print here, but we should get into actually what this is. So everything I'm doing, you'll notice, has this print in front of it and parentheses around it. So this is a function call. This is what's called a built-in function. And somewhere in Python, there's a definition of what print is supposed to do, what we call a definition. And a definition just defines some process for how to do anything, how to do something. In this case, the process defines a process, or the definition specifies how to do a print, right? So functions have a definition and then they have an invocation. So this function is already defined for us. We're going to be talking about later. We're going to be talking about how to write our own functions, and we're going to be doing a lot of that. But this is an invocation of that, and what it means, what invocation means, is that we're actually using it. We're calling on that code to invoke it and make it run. So print, there's a number of functions that are already built into Python for us. Print is a really useful one. It's a simple one. All it does is just display something on your console. That's all it does. But it's really your only way of seeing what's happening in your code. So whenever you get stuck, just start thinking about, what can I print off? I mean, even think like, what can't I print off? Just try printing, try putting a print around everything in your code. Worst that's going to happen is you're going to get an error, which is not a bad thing. So print is the way that we're going to make things visible in the console. Another built-in function is type. So if I want to know the type of something, type, this is another function. So I say the function name and then I put parentheses after it. All functions, in order to invoke any function, you have to put parentheses after it. And inside the parentheses, we will pass arguments, what we call arguments. You can think about them as inputs into the function, right? So print takes any number of inputs of any type, and if it's printable, it will print it. It'll make it visible on the console. Type takes any type, and it gives back the type. It gives back a little description of what the type is. When a function gives us something back, we call that a return, right? So it's important to think about every function you learn, think about what are its inputs and what are its outputs, right? So it's kind of weird. Print technically doesn't have an output, even though it looks like that's its main thing, is to output to the console, right? But it doesn't have an output in the same way that most other functions do. Type does have an output, so type does return a value. Output and return, when you hear me say output or return, those are basically going to be synonymous in this class. So if I want to know the type of 4, run that. Oops. So this says it's a class int. and I could also get the type of 4.3, and that's going to be a class float, right? And all I need to do, anything I put in here, just has to evaluate, it has to simplify down to some data type, right? So I could even put a math expression in here, 4 plus 7, that's going to be 11, right? So 4 plus 7 is 11, and since 4 and 7 are both integers, then 11 is also going to be an integer. Same deal if I do 7.0 here, then I'm going to get a float since I'm mixing an int and a float. Cool. And then same thing, if I put in, oops, if I put in this, right? Remember, this didn't give us back a number, this gave us back true or false, right? So Python says this is a class bool. Oops. Just do this. Sorry. I'm just going to kind of clean this up a little bit. There we go. Int, oops, no, this is a float. And this is a float. Okay, there we go. Cool. And we got a couple questions here. Do you have to put spaces between the numbers / other functions inside the parentheses? You don't have to. It's something that I like to do. I notice it aids in readability. In a simple line of code like this, it's not so bad to not have spaces. Let's see. Let's actually just kind of compare the two. So this versus this. So if I don't put the spaces in, things can kind of start to get jumbled up, and it's not so bad when I am just passing one function to another function, right? But if I'm passing a function to a function to a function, and maybe I'm passing two functions to one, it's like things can get crammed together, and it can be hard to visually see where something ends and something else begins without just like really squinting and like picking your way through it. So I add spaces in by default because it just kind of spreads things out and makes things a little clearer and more readable. So that's a stylistic thing that I do. I'm the only person that I know that does this particular thing, but yeah, you can do it or not. It's just a stylistic choice. That's up to you. Mostly I do it. I mean, I do it most of the time is what I meant to say. Comment these out. Okay. Cool. So this is just going to talk about ints, floats, and bools, which is what we just went over. So integers can be thought of as whole numbers. Floats can be thought of as decimal numbers, excuse me. Ints and floats are encoded differently in memory. I talked about that a little bit. If you want to like dive down that rabbit hole. It's interesting, but it's not something, if you're new to Python, if you're new to programming, it is not something that you need to understand right now, or anytime soon. The way that information is encoded, I find to be really interesting. So I won't discourage you from learning it, but don't think that you have to know it in order to just like do programming. This is the example that I gave before. 1.0 is equal to 1, gives us back this Boolean value of true. Of course, if this was 1.1 equal to 1, this would give us a Boolean value back of false. The type, now this is an interesting thing, right? This is checking if the type of 1.0 is equal to the type of 1. And let's just make this a little experiment here. So let's see if 1.0 is equal in value to 1. And we'll do another experiment here. We'll say, let's say 5 equal in value to 1, and 5 equal in value, or equal in type to 1, right? So you can see how useful Booleans are. Oops, we'll do this. Sorry. There we are. Cool. So 1.1 is equal to 1 in value is true. Type of 1. Excuse me, I said 1.1, I meant to say 1.0. Type of 1.0 equal to 1 is false, right? So they're not equal in terms of their type. 5 equal to 1 is false because 5 and 1 are different values, but the type of 5 as an integer and the type of 1 as an integer are equal because they're both integers, so that's true. It's an interesting little experiment. Okay. So we've got a breakout here. So I'm gonna take a screenshot. And I'm going to copy this text. I'm going to put 3 minutes on the clock. And once you get your answer, just paste it into the Slack thread or the class thread. I meant to mention too, you can include your code and the result of that code as well. All right. That's time. Feel free to put in your answers. Okay, so I'll give this one a quick solve, just if you're struggling. I'll show how to do this one. Use the type function to discover the type of the number 74. So 74, let's do this on line 74. And we'll say type. So you might have tried to do this and run your code and then notice nothing happened. You'll need to print, if you want to see the results of type, you will need to print it out. So you'll need to pass type to print like that. And you can see we get class int. So what I always like to do if I want to see the output of something, if it has a simple output, if it just gives out, if the output is just one line, sometimes I'll just keep it in a comment there, like that. Cool. And then using a comment describes simply what you did in the line above your code snippet. Okay, so for this, I might say something like passing 74, the number 74 into type. So when we give something an argument, we call that passing that argument. So I'm giving type the argument 74, the input of 74. And so I'm passing 74 as an argument to type. That's how we would say that, passing it as an argument. And then, so passing number 74 into the type function and passing the type function into print. Something like that. Cool. Simple operations in Python. So we basically covered this. This is just mathematical operations. So if you're curious, Python follows the order of operations PEMDAS, because if it didn't, that'd be pretty bad. I forgot to mention parentheses, which is important. So let's do a little bit more math. So I just showed some basic operations, but obviously operations can get more complicated than that. So you can ignore these parentheses here, and I'm just going to give myself extra space just so that just so you can kind of ignore them more, ignore those parentheses. So let's say I wanted to do 7 plus 3 times 15, right? So, or let's just do times 10, right? So is this 3 times 10 plus 7, which would give me a total of 37, or is this 7 plus 3, which is 10, times 10, which is 100, right? So what should this give me back? Go ahead and put it in Slack. $37 or 100. Yeah, exactly. And that's because this follows order of operations, right? Multiplication is going to happen before addition regardless of its position, right? So if I run this, that's going to say 37. So 10 times 3 plus 7, right? Now let's say I wanted to multiply by 10 whatever the sum of 7 plus 3 is. Well, I have to put 7 plus 3 in parentheses here. So one thing I say is always err on the side of more parentheses than you need. I'm sure you'll hear. I'm sure people. I'm sure a lot of people would disagree with me on that. The reason, though, that I say this is because, let's do this. Oh no. The reason I say err on the side of more parentheses is this line, for example, this doesn't need the parentheses. But the difference between, so these two lines are both going to give me 37. So you might say, oh, I'll use the one with fewer parentheses. And that's fine. I mean, if you know what you're doing, you can do what you want. If you feel confident, very confident in this domain and you're comfortable here, like, you don't have to do what I tell you. But the reason I prefer this, though, is because it's explicit. It's saying, yes, my intention is to do 3 times 10 first and then add 7 to that, right? So I will use parentheses even in places where I don't need them, even in places where I know the order of operations is going to do it in that order anyways. But I don't care because I want my code to be explicit. I want it to be clear what my intentions were. With this, it's, I mean, if I in earnest wrote code like this, hopefully it would be clear that, my intentions were to do 10 times 3 and then add 7 to that, but it leaves it a little open to interpretation. If there's some problem with this code later, I have to go through and think through this and think, okay, did I what's the intent of this? What's the reasoning behind this bit of math? And I have to go through and pick through that, and maybe I realize that, oh, I needed to do it the other way, right? But with this, it's hard to put parentheses. It's harder to put parentheses in the wrong spot than it is to assume that order of operations is going to do what you want it to do and then have it not do what you want it to do, right? So just always assume order of operations, the natural order of operations. Always assume it's not going to do what you want it to do, and then just parenthesize according to what the order of operations should be. So using parentheses allows you to explicitly declare your intended order for how things should be evaluated. So that's my recommendation. I would prefer this line of code over this line of code, even though they do the same thing, even though the other way has kind of less going on. I still prefer the more explicit, clearer way. Okay, cool. So duck typing. Duck typing. Python is a quote-unquote duck-typed language. The reason it's called duck-typed is there's this cute and not very clear analogy of if it walks like a duck and it quacks like a duck, then it must be a duck. So effectively, this means you can perform mathematical operations between similar types, such as ints and floats. So this is a concept that I covered before, that we can mix integers and floats when we're doing mathematical operations because they're both numbers, and Python knows how to convert one type to the other kind of implicitly. So basically, if it walks like a duck, it quacks like a duck, we can do math with it, I guess. But formally, officially, that typing system is called duck typing. Okay, we got another breakout here. Is that it? Okay, cool. So there's your breakout instructions. I'm going to put 5 minutes on the clock. Feel free to get started. Okay, that's time. So for this, here, I'll just delete this and do this again. So this says add 5 and 7.2. Add 5 and 7.2, so we'll say 5 plus 7.2. Multiply that result by 6. Divide that result by 3. Square that result. Okay, cool. So add 7 or add 5 and 7.2. Multiply that result by 6, so that'll be times 6. Oops, times 6. Divide that over 3. And then square all of that. There we go, and that's going to be, oops. 595.359, etc. Cool. That's yesterday's homework. Okay, on to the next slide deck. We already took kind of an early intermission. I don't want to totally stiff you guys on a break though, so let's just take a real short break. If you need to use the restroom or go refresh some water, let's reconvene at 15 after the hour. There we go. Sorry again about the bright light on my camera. I'm getting a lamp for my proper desk lamp that should have a nice light so I don't blind y'all. Okay, cool. So this has some review of the prior slides in it that we don't really need because we literally just went through those. This is just talking about integers, floats, and booleans. Again, numeric type encoding, int and float data types are encoded differently, but they are able to share operations in Python. So I actually forgot to mention this. somebody asked this. I showed plus, minus, times, divides, and modulo, but I forgot to show exponentiation, which is my bad. But that's star star. So if I wanted to do 4 squared, I have to do 4 star star 2, right? In other languages and standards, you might be used to using the caret operator or super. There is no actual superscript since we're in plain text here, but this is not. This is an operator in Python, although it's a really obscure one. I don't know that I've ever actually used that operator, but star star is the exponentiation operator. So Python is a duck-typed language. We went over what that is. Simple operations. Here's another one. So casting. Sometimes this won't come up for a few lessons, but it'll be important later. And in understanding how to convert one data type to another. The term we use for that is casting, not converting. I wish we just called it converting because it kind of makes it, I don't know, kind of seems like an obvious one, but it's called casting, unfortunately. So let's say I have an integer and I want to, let's see, so let's say I have an integer and I want to cast it as a float. So I can use the float function, float, float, and that's going to give me an integer or a float version of that. So any integer that I cast as a float in this way, it's going to have a whole number representation. In other words, it's going to end in 0.0, but it's going to be a float, and it'll still have the same value. If I have, let's say I have a float and I want to change it to an int, I can change it to an int just like that. What happens if I have an actual, fractional component on there? It's going to just get chopped off. So in either of these cases, let's just do this. The answer is just 4. So this is going to dive into the arithmetic operations a little bit. Let's see. I do want to talk about the division operations because they're there's 3 of them, kind of. So let's do 10 over 2 and 10 over 3. So this is standard division. This is just regular division operator. Notice that 10 is divisible by 2 evenly, right? So 10 over 2 is 5. 5 is a whole number. But notice, even though this value could be expressed as an int, it's expressed as a float. Think about that for a second, right? So this value cannot be expressed as an int. It has to be expressed as a float. So think about how it would be if division, and I mean this may make sense to you, but to me it would be really weird if division sometimes gave me an integer back and sometimes gave me a float back, depending on whether the number could be evenly divided or not by that number. This would mean if division only gave us an integer sometimes, or only give us a float sometimes, it would have kind of an inconsistent and unpredictable return value, right? The thing that it evaluates to, the type of the thing that it evaluates to, wouldn't be consistent. And you might look at that and say, well, yeah, but an integer is kind of cleaner and nicer to look at than a float, or like it's simpler to store in memory, so why not store an integer rather than a float? Or why go through the trouble of returning a float if it's going to be a whole number value anyways? And the reason for that is you want operations to generally evaluate to the same type, right, every time, given the same types of inputs, right? So for two integers or for two floats or for any mix of float and integer, I know that single slash division, no matter what, just gives me a float back. Other operations, right, like addition, and this is going to be said for most of the other operations as well. 5 plus 3, right? Well, this is going to give me back an int. 5 plus 3 is 8. But if I change either or both of these numbers to a float, it gives me back a float. Right? But in this case, it's still a consistent, it still gives me a consistent return type for a given input, for given input types, right? So I know that if both of the inputs are integers, the output will be an integer as well. Otherwise, it'll be a float, right? So this is still consistent, even though there's times when plus will give an int, times when it'll give a float. You know when those what those times are based on the types of the operands. Whereas if addition worked this way instead of this way, you wouldn't be able to know that, right? So that's kind of a weird quirk, something to get used to. Sometimes you just want to see how many times a number goes into another number, right? So you just want to see, well, how many times does 3 fully go into 10, for example? So for that, we have floor division. So 10 floor divided by 3. So that's just slash slash like that. Sorry, this is just kind of muddy, unclear output. So this is going to give me an integer back, or rather, floor division always gives you a whole number value back. Same thing, it works the same on that level as addition, right? If I do this, this is going to give me, these 3 are going to give me floats, and this is going to give me an int. It's the same pattern as with addition or other normal operators, right? Cool. And finally, let's look at the remaining type, the remaining division operator, division adjacent operator, which is modulo. So if I say, if I want to know the remainder of dividing B into A, so let's say 3 into 10. So what's the remainder of 10 over 3? I'll use the percent symbol. Now this is weird. It's the percent symbol. It's the symbol that you're probably used to calling percent or percentage. It's the percentage symbol. What it does is give you the remainder. So you'd think, oh, well, it's called the remainder operator. Often I will call it the remainder operator just because that's what it is. But its proper name and what you should learn to call it is the modulo operator. Usually we'll call it mod for short. So the way we'd read this is 10 mod 3, which is 10 over 3 remainder. What's the remainder of 10 over 3? And that's going to be 1. So 3 times 3 is 9, and so 3 goes into 10 3 times with a remainder of 1. In terms of these being, the whole, in terms of using floats with these, it's going to give you the same thing. The thing is, you tend not to really use modulo with floats as operands. You tend not to really use modulo with negative numbers either. Sometimes you will, but not really. So the major case that you have to understand using modulo is with positive integers, positive whole number values, which is nice because that's the easy ones. Those are the easy numbers, right? So I'm just going to kind of, brush that aside. Like, yeah, you can use it with floats. It doesn't really come up that much. And the behavior gets kind of weird with like fractional values and stuff. So we'll keep it simple, and we'll just say, we'll just think about it with positive integers for now, because that's most of the way you use it anyways. Cool. Let me see. We skipped a breakout there. Modulo, negative modulo, breakout. We've still got plenty of time. I do want to get to, assignment though. I want to make sure we have plenty of time to go over assignment. So earlier somebody asked me, what's the difference between double equals and single equals operators? So if I want to see if two things are equal, I can use the equality operator. Single equals, you might think, oh, well, it kind of looks the same to me. So single equals does something totally different. And you use it all the time in a way that looks pretty intuitive and feels pretty intuitive. But what it actually does is assigns one value. It assigns a value to an identifier. So it lets us make a variable. So we'll talk about variables. So a variable is just something, it's some piece of data that you give a name to, right? So if I want to say A equals 5, the way I should actually say this, and I'm guilty of not saying it this way, but the way I should actually say this is A gets 5. I am assigning the value 5 to the identifier A, right? So this name portion is called the identifier. The single equals is called the assignment operator, and then the right-hand portion, 5 in this case, is the value. So I'm using the assignment operator to assign the value 5 to the identifier A. Okay, so what does this mean? Well, anywhere where I use A now, it evaluates to the value I assigned to it, right? So and I could just assign a value, or I could assign the result of an expression. So I could say A equals 5 times 3, right? So this expression, this doesn't, I didn't write, it's called an expression because I didn't just write 15. I wrote something that expresses the value 15, right? So 5 times 3 will be 15. That expression, this code will evaluate. It will evaluate to the value 15, and then that after it's done evaluating, it will that result will be assigned to A. So if I print this off, I'll get 15. And then I can use this. Let's say I have B equal to A over 2, right? So B equals A over 2. Well, that's A is 15, and 15 over 2 is 7.5. So B is equal to 7.5. Of course, I could do C equals A times B. And we get print C, 112.5. Right, so you can see there's this pattern of, like, we have some expression. That expression gets evaluated to the point where it can't be evaluated anymore, and then it just expresses a value. That value, that is the result and is assigned to an identifier, and then we can use that identifier as that value. Somebody's asking, are identifier and variable interchangeable? The way I use the term, the reason I use the term identifier is to be a little more precise than variable. When we talk about something being a variable, this to me is a variable. When I create the variable, right? A variable has multiple components to it, right? It has an identifier, it has an assignment operation, and it has a value, right? The identifier is just the name. Often we'll refer to this as like the variable C or the variable A or the variable B. But when I want to talk about the variable and specifically talk about its name, I call it an identifier. But so there's overlap, but they're not 100% interchangeable, if that makes sense. Variables like the whole thing, and identifier is just the name portion. But often in practice, we'll just probably call everything a variable. I just want to establish that language so that we can be precise when talking and communicating about these things. So 5 is the value. Yes, 5 is the value, exactly. Cool. We can also reassign values, right? So yeah, let's just do this in another experiment here. Let's make another little section. So let's say I have A equals to 5 and B equals A plus 3, and then I'm going to say A equals 0. So if I print A is going to be 0 here. If I print it before, A is going to be 5, then A is going to be 0, right? So ask yourself what your intuition tells you B is going to be, right? So A is equal to 5, B is equal to A plus 3. 5 plus 3 is 8. And then I set A equal to 0. What is B equal to? What does your intuition tell you B should be equal to? Go ahead and put it in Slack. And this is just a test of your intuition. You know, like maybe you trust that intuition, maybe you don't. Cool. Yeah, so B is going to equal 8. And I wanted to point this out. It seems like that's obvious to most of you, which is good. But I think I saw a couple people put in 3, right? So I want to point this out because it can be easy to think, oh, well, since I reassigned A, that's going to change what B is. But the way that this happens, the way that Python is evaluated, the Python interpreter evaluates a Python file from top to bottom left to right. It evaluates each line from left to right, and it evaluates the lines in order from top to bottom, right? And at the time that B was assigned a value, A was equal to 5. So B captures the value A plus 3, which is 8. B just captures that value. So B's value is 8. I can do whatever I want to A. I can delete it. I could change its value. I could make its value a string. But B already captured the value 8. So that's set in place unless I explicitly assign B a different value, like 1000 or something. Then B is going to have a different value. So the only way B's value is going to change is basically if I change it. Cool. Also, it's always good to like take note of what your assumptions are as you go through this. I hope I'm not like putting anybody on the spot, like with that. It's just good to take note what your assumption is, check that assumption, and if you're wrong, you learn something, and if not, then you learn something anyways, so either way. Somebody's asking, Python is assigning a block of memory, giving it an alias or identifier, of B, and filling it with the value 5. Then it receives an update in memory and replaces the pointer for B with 1000. Yeah, that's a way of looking at it. Cool. Yeah, so that's the assignment operator in a nutshell. Let's see, what else can we do here? Yeah, let's look at this. A equals 0. And I'm just using single letter variable names because it's easy, but I want to be clear. I could call this anything I want to call it. I can give this any name that I want. So some variable. Print some var. It's convention in Python that if your variable name has multiple words in it, that's totally fine to do, but that you separate the words with an underscore. I strongly recommend that you follow that convention. There are conventions that are a little bit open to interpretation. Like there are things that I do my way that aren't the PEP8 way, but I do them my way because they're kind of a little open to interpretation. And then there are things that really that are really nice to have standard. Now, technically, you could, if you're familiar with like a different casing scheme, like you could use camel case or Pascal case or some other casing, but it is strongly recommended that you use snake casing, which is what this is, and it's kind of cute, I guess, that the language is called Python and this casing is called snake casing. I guess because it's like it's low to the ground. It's like a snake slithering on the ground. I don't know. That's the analogy that I thought of. But yeah, it's called snake casing, and basically it's just underscore separation of words. So yeah, you can. There's a lot of flexibility in how you can name your variables. For this just little toy exercise, I'm just going to continue with single letter variables for now. So, oops, I'm going to start A at 0. So it's really common to want to use, let's actually call this a counter. Let's make a counter. It's really common to want to make a variable and change it relative to its current value, right? So I might just want to add 1, I might want counter's next value to be whatever its current value is plus 1, right? So the way I can do that is I can say counter equals itself plus 1. And what this is saying is counter equals its current value plus 1. Counter plus 1 is 0 plus 1. 0 plus 1 is 1. Therefore, counter equals 1. Is there anybody that's a little confused by that, or is that clear? Give me a thumbs up if that's clear, or a thumbs down if you're no good on that. Give you all a second. Okay. Seems like everybody's good. So you can see I set counter to 0 and then print it. Then I change its value, print it, change its value, print it. And you can see in my console 0, 1, 2. Oops. Let's just do this a few more times. 3, 4, 5, right? 3, 4, 5. So it's really common to do this. So you can do it this way. Convention, though, is to do this. So since it's so common to change a value according to its current value, especially numeric values, we can do this syntax. This is what's called syntactic sugar. Whenever you hear something called syntactic sugar, think about it as like it's syntax that makes some existing process sweeter. It makes it a little nicer. It's like putting sugar on it, right? So this doesn't do anything that doesn't already exist in Python. It just makes it a little cleaner and a little nicer. So this line and this line are exactly the same. These two lines are exactly the same line. In fact, the Python interpreter reads this line and internally it rearranges it, it rewrites it essentially as line 155. So it takes line 154 and it turns it into line 155 under the hood, right? It is convention to do this plus equals though, like this. And we can use actually any operator. So I do want to make something clear here though. I cannot, let's do counter equals 0. I cannot start a variable like this. And the reason is, this is like saying counter equals counter plus 0, or we could just do plus 1. If I do this, I'm going to get this error. It says counter is not defined, right? And this is going to happen with any variable that I try to use, like let's say foo. Foo is some variable that doesn't exist. It says name error, name foo is not defined. So we can't use this because we haven't defined it. So I could say foo equals 10, and then I could say print foo. So now foo exists, we can use it. Okay, cool. So the same thing, since plus equals gets rewritten as, I'll use foo here, since foo plus equals 0 gets rewritten as foo equals foo plus 0, if foo didn't have some value to put in here from before, then that's a problem, right? So we have to make it exist first, and plus equals will not do that. So there has to be some initial assignment before you can use plus equals. Another thing is we can do this with any operator. So I could do, let's say, counter, or let's just call this num equals 10, and I'll say num plus gets 15. Let's print num. Okay, so we got 10 and 25. Let's do another one. Let's say num minus gets 8, right? So 15 minus 8 is going to be 17, or excuse me, 25 minus 8 is going to be 17. We can do, right? And that's because this gets rewritten as num equals num minus 8, right? Now you might notice, like, you might think like, well, it doesn't matter which order. When you're doing addition, 10 plus 5 and 5 plus 10, it doesn't matter. They're the same thing. But 10 minus 5 and 5 minus 10 are two different numbers. So you might be thinking, well, what if I wanted to do num equals 8, or let's say like num equals 50 minus num? Like, how would you shorten it to this num minus equals thing? And you can't. So this minus equals won't work for this operation. So 50 minus equals, or num equals 50 minus num is, oh, well, of course it's 25. Let's do 80 minus num. Oops, 80. So that'll be 55. So remember, 80 minus num is at this point 25, right? Because we start num at 10, we add 15 to it. 10 plus 15 is 25. Then 80 minus 25 is going to be 55. Right? So if I wanted to do things in this order, I have to do the long form way. I can't actually do the short form way, because the short form automatically puts things in that order. Num minus equals 8 always turns into num equals num minus 8. So just so you know. And we could extend this logic basically out to the other operators. Multiplication, division, floor division, modulo, and exponentiation can all be used in this form. And the behavior is always the same. You just take the operator and the identifier, you do num plus 15, like that. Cool. Okay, so let's do a little, we're actually running light on time. I'll save that exercise for another time. Just trying to find things we can fit in to the remaining time that we have. All right, scalar types. So all the types that we've talked about thus far, all the data types that we've talked about, are what are called scalar types. So scalar types hold one single value at a time. So they represent a single value. There are like collection types that can hold a multitude of values, but scalar types hold one single value, and they are immutable, which means that we can't change the data type. We can't change anything about the value itself. We can change what the identifier, what the pointer is pointing to. We can change the variable, what that's pointing to, but we can't change the identifier itself. So far we've mostly discussed ints, floats, and bools. Other scalar types are strings, which we mentioned briefly and we'll get to later. The none type, complex, and byte, and there's also tuples in there as well. Cool. And let's try to get a couple more breakouts in here if we can. I don't think we did this one. Print the result and multiplying 7. I don't think we did that one. Yeah. So you can submit your code, and the result of each part of your code for each of these in a comment below it. And I'm actually going to put 3 minutes on the clock for this one instead of 2. All right, go ahead and get in your answers. And I'm just gonna paste these in real quick so you can reference the answers if you want, kind of see some other solutions. Cool. We're actually close to time for the day, so I think this is a good place to wrap up. Feel free to pop in your answers if you're still working on this challenge. Yeah, I'll end class here. If you're ready to be done for the night, then enjoy your night. Homework is in, if you go to that class repository that I sent in at the beginning of class in the thread, you can find it in there. You can also find the homework if you click on the message where I sent in the Zoom link, the class thread message. It has two links to two slide decks. One is Intro to Python, and the other is Python Basics. So the homework for today can be found if you click on Python Basics and then scroll to the very bottom, and you'll see links to the homework and descriptions on what to do from there. Cool. If you're done for the night, then have a good rest of your night. I will see you tomorrow. And if you want to stay on for questions, then feel free to do that as well. I'm just going to stop the recording.